Bismillahirrahmanirrahim. Today, inshallah, we will talk about the angle bisector theorem. Angle bisector theorem, okay? So now, last time we talked about the perpendicular bisector theorem. The angle bisector theorem is very analogous to the perpendicular bisector theorem. If you recall, the perpendicular bisector theorem had said, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of a segment, like I've shown in this little diagram over here. And if you recall, I suggested that the perpendicular bisector theorem is more about the points that are on the perpendicular bisector than about the perpendicular bisector itself, because it says the points on the perpendicular bisector are equidistant. The converse of the perpendicular bisector theorem was that if a point is equidistant from the endpoints of a segment like this, D over here, then it's going to lie on the perpendicular bisector. That was the converse of the perpendicular bisector theorem. It's a very important theorem. Now, the angle bisector is very analogous to the perpendicular bisector, and the theorems are very analogous. So I'm going to first state the angle bisector theorem, and then we're going to try to provide a proof, inshallah. This is what the angle bisector theorem says. It states, if a point is on the angle bisector of an angle. So again, we notice that the theorem is more about the points that are on the angle bisector. If a point is on the angle bisector of an angle, then it is equidistant from the sides of the angle. So I have here an angle A, B, and C, and I have this angle bisector over here. Let's call this AD over here. Okay. So if a point such as point D over here is on the angle bisector, the theorem said that it is equidistant from the sides. I mean, in this case, it's going to be side AC and side BC, AB. So let me draw this out. Now, the way you measure the distance between a point and a line is the shortest distance, or the perpendicular distance. So you have to draw a perpendicular distance like this from D to this side, and from D to this side right here. Okay, so the theorem then states that since D is on the angle bisector, okay, which is AD here, then it is equidistant. That means this distance equals this distance over here. Okay, so we can call this point E and this point here F. So the theorem here says that EF is going to be congruent to, ED is going to be congruent to FD, like this. Okay, so if a point is on the angle bisector, then it is equidistant from the endpoints, equidistant from the sides of the angle. Okay, now how do we go about proving this? Now I think you can foresee the proof over here. The proof would be as follows. Okay, so what we have to prove is here that DE is congruent to DF here. So those two segments, okay, that's what we have to prove. And as you can see over here, there are two triangles over here, correct? That's one triangle and that's one triangle. If I could prove those two triangles congruent, then I could prove that the two segments are congruent by CPCTC, CPCTC. Now the question is, how do I prove those two triangles congruent? Well, I have this angle here. Those are right angles, right? Okay, because I'm given that D is the angle bisector, right? And then I have these two angles, that's from the D being angle bisector. So I have angle and angle, right? But is that sufficient? No, we need something else, right? We need something else. So we have at our disposal side, side, side. That's not going to work because we don't have any sides over here. Side, angle, side. Angle, side, angle, and then angle, angle, side, hypotenuse leg. Okay, you might think we might be able to use hypotenuse leg here because we have a hypotenuse, right? Oh, very good. But we don't have a leg because this is not given. That's what we're trying to prove over here. And this we don't know. We can't prove that, okay? So we can't use hypotenuse leg, but we had this insight now at least that we have one side that reflects a property, right? So now I have wait a minute, I have angle and I have angle and I have side. So I think that's going to work. So I can prove the two triangles congruent, I think, by angle, angle, side, and then CPCTCs. Okay, so that's how we're going to do it, inshallah. So statements given is D is on the angle bisector, which is AD. Okay, that's given to us. Okay, so from this, what information do we derive? What we derive actually from this is that angle EAD is congruent to angle CAD. Okay, that's from definition of angle bisector. Okay, so now you got that. Okay, number 3. Okay, then we say, okay, AD is congruent to AD. Okay, now that's by reflexive property, correct? It's going to be by reflexive property. All right, we got that. Now we say, okay, now we can say the following. Okay, angle DEA and angle DFA are right angles. That's given because that's how you measure the distance between a point and a line. Okay, so this is going to be given information. Okay, and then we say these two angles are congruent. Angle DEA is congruent to angle DFA because of right angle congruence theorem. All right angles are congruent. And then we say, see, now we have angle, angle, side. Okay, then we can say triangle DEA is congruent to triangle DFA. And that is because of angle, angle, side. And then finally we can say 7. We can say DB is congruent to DF. And that is because of CPCTC. Okay, and ta-da, and we are done. So that's the proof of the angle bisector theorem. So it's very important. Both of these theorems, the perpendicular bisector theorem and the angle bisector theorem, are very important. Next time, inshallah, we'll talk about the converse of the angle bisector theorem. But again, the summary angle bisector theorem states if a point is on the angle bisector of an angle, where else is going to be, then it is equidistant from the sides of the angle. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.